Hello everyone, in the previous videos we have discussed about the single bus architecture. We have taken the example like addition and we have taken the control sequences which are used for the execution of that particular instruction, right? So here whenever we are dealing with the single bus architecture, we said that the single data, nothing but the only one data can be transferred over the bus in a clock cycle, which makes us for the more number of control sequences. If we want to reduce the control sequences to be less, the more number of control sequences if we don't want, then the more than one data has to be accessed simultaneously. For that we will move with multiple bus organization. Here you can see, so all the general purpose registers what we have used in the single bus architecture, it has been put into a single block which is called as register file. So this register file is having three ports, two output ports, which allows the content of the different register to be accessed simultaneously, and that information can be put onto the buses A and B. So you can see here we have the block register file. So here we are seeing two output ports we are having, so which makes us to access the data simultaneously from the two different registers, and it can be put on bus A and B. Next we have third port, which allows the data on bus C to be loaded into the third register during the same clock cycle. So now in the single bus architecture, only one data can be accessed in a clock period. When you go with the multiple bus organization, more than one data can be accessed simultaneously. Right? It can be accessed simultaneously between different registers, and it can be put onto the buses. That is the plus we have with the multiple bus organization. So here, so the buses A and B are used to transfer the source operands to the A and B inputs of the ALU. You can see here. So these inputs what we are getting from buses A and B, it is used to feed the input for the ALU, where you can perform your arithmetic and logical operation. So here the result can be transferred to the destination C. It can be transferred to the destination over the bus C. If it is needed, like the ALU can simply pass one of its inputs operands unmodified without modifying to bus C. It can send the information, that is the input which is present in ALU. It can send it directly on the C without modifying by using the control signals like R is equal to A, R is equal to B, where the ALU is directly sending the input information like A or B directly over C without any modification. Next we have incrementer. So this incrementer is used to increment the content of the PC. So already we know, so PC will be holding the address of the location from where the instruction has to be fetched and executed. Once it is done, it has to move to the next location, therefore it has to be incremented. That is why we are moving with the incrementer. This is to increment the content of PC. So this is a general purpose register here to perform all your arithmetic and logical operations. So we have the decoder for that to generate the control signals for the execution of an operation. We have instruction register, which is used to hold the current instruction to be executed. MDR, that is memory data register, and MAR, that is memory address register. So here when we are using increment, it will be eliminating the need to add 4 to the PC using the main ALU. But still we are using the constant 4, which is in the part of ALU, which is used to increment the addresses, such as like memory addresses in load multiple and store multiple instructions. So let's take an example to understand this multiple bus organization to perform a operation using multiple bus organization. So here we have taken instruction which is saying add R4, R5, R6, nothing but you will be adding the contents of R4 and R5, and you have to place the result in R6. So in the previous example, we had taken an example which was like add the content which is pointed by memory location, the address which is present in R3 with the content which is present in R1, and we have to store the result. So for the execution of this instruction, I think we have taken 7 control sequences, right? So now we have an instruction where we are saying two contents, the two information which is present in R4 and R5, it has to be added and it has to be stored in the result. The result has to be stored in the register R6. For that we have taken almost only 4 control sequences. right? In the previous, when we are dealing with the single bus organization, we have taken 7 control sequences. When we are moving with the multiple bus organization, the the control sequence is what we need, it has been reduced. So now in the first step, you can see here. So in the first step, now the contents of the PC are passed through the ALU. Through the ALU, it is sent. So using the signal R is equal to B. So the content of B are directly sent over the bus, and it has loaded into the MAR. That is your memory address register. The content of PC are directly sent and it will be loaded into MAR, and we are initiating a read operation, that is memory read, and after this reading is done, after this read has been initiated, at the same time we are incrementing the PC so that we can go to the next location. Now the value which is loaded into the MAR is the original contents of the PC, and the incremented value is loaded into the PC at the end of the clock cycle. This is step number 1. In step number 2, the processor waits for memory function completed and loads the data received into MDR. That is WMFC. Wait for memory function completed. In the step 3, the contents of the MDR are transferred to instruction register, and in step 4, we have the execution phase. This single instruction, that is single step 4, is for your execution phase. So we know the instruction will be executed in 2 steps. One is instruction fetching, and the next one is instruction execution. So now till now we did about instruction fetching. Now in the last step, which is saying about your instruction execution. So now you can see here the contents which are present through the 2 buses what we have used, buses A and B. So those 2 contents has to be added, and it has to store the result in R6, and end says this is the end of your instruction set, nothing but your control sequences. This is how we can reduce the number of steps involved, number of control sequences we needed in case of multiple bus organization. If we use single bus organization, the same set of instruction, the set of instruction we need for the execution of this instruction, that is add R4, R5, R6, it will be more than 4. So that is what the plus we have to move from single bus organization to multiple bus organization.